Hello again, and welcome to another math tutorial. In this video, we're going to look at how we graph linear inequalities in two variables. We have already studied solving and graphing solutions to inequalities in one variable on a number line, and today we're going to do it in two variables. Let's get started with the first example. Okay, we're asked to graph the inequality y is less than or equal negative 2x plus 3. So I have the steps that we're going to follow typed out here. The first step that we want to do is we just want to plot the points of the boundary line. So that would be just like plotting out the points of your line like you're used to. So you're going to do y-intercept and then slope. So this line has a y-intercept of positive 3. So we're going to start right there, positive 3. And it has a slope of negative 2, which is the same as negative 2 over 1. So we're going to go down 2 and to the right 1. And we can keep plotting points down 2 and right 1. Okay, now we need to connect the line. And so we're going to connect the points with either a solid line or a dashed line. Now, we will use a solid line every time we have a greater than or equal to or a less than or equal to. Okay, so the key is it has to be equal to get a solid line. We're going to use a dashed line every time we have a greater than or a less than. Okay, so you can think of the solid line as like a filled in circle on a number line that's used when we're equal to. And you can think of the dashed line as like the open circle on a number line that we would do if we don't have equal. Okay, so this inequality up here has an equal to underneath it. And since it has an equal to, we're going to connect these points with a solid line. Okay. Now, after we've connected the points, we have to shade one side of our line. Just like on a number line, after we do our open or closed circle, we would then shade in to the right or to the left on that number line of that point. This is the same exact thing. We need to shade either above or to the right of this line, or we need to shade below or to the left of this line. And the way we're going to shade is we are going to shade above the line if we see a greater or greater than or equal, and we're going to shade below the line for a less than or equal to. Okay, so back to this line, we have less than or equal to. Less than is going to imply everything beneath the line or to the left if we're thinking like on a number line. So all I'm going to do now is just take my pencil and I'm just going to shade this graph in. Okay, so just like on a number line, what we're implying is that anything over here in the shaded area, okay, if I were to take any point, so for example, let's just do like a quick play this out. If I were to pick any point, say this point right here, which is the point negative 3, negative 4. If I were to take that negative 4 and put it in for the y, if I were to take that negative 3 and put it in for the x, that should make this a true statement. Okay, I'd have negative 4 is less than or equal to 6 plus 3, which is negative 4 less than or equal to 9. And yes, that's a true statement. So what we're finding is that any point that lives down here where it's shaded is going to be a solution to this inequality. Okay, the next example problem, we have y is greater than 1/3 x minus 2. So let's run through these steps again. We start with the boundary line points. So we're going to start at minus 2 on the y-axis. Slope is 1/3, so up 1 and to the right 3. I'm going to go off the graph if I do that again. So let's go down 1 and to the left 3. So 3 points, that's pretty good for drawing my line. There's no equal to, so we're going to use a dashed line to connect these points. Okay, so just a nice dashed line. All right, now we have greater than. Greater than implies that everything that lives above the line are where we're going to find solutions. So we're going to simply shade everything above this line. And I'm not going to do it like we did in the last example, but if you pick any point that's above this line and plug it in, you're going to find a solution point up here. Okay, next line is 2x minus 3y is less than 9. Okay, so first things first, I want to change this into slope-intercept. Remember, slope-intercept form is solving this for y. So I'm going to start, let's just rewrite it and then I'll go from there. 2x minus 3y is less than 9. So I'm going to bring the 2x over here by subtracting it. That's going to give me negative 3y is less than negative 2x plus 9. Now I'm going to divide the negative 3 off of the y. So that's going to give me y. Now, I have divided by a negative, so don't forget your rules for division or multiplication by a negative number in regards to inequalities. That's going to change the inequality direction. This will now become 2/3 x and minus 3. Okay, so let's see what this looks like on the graph. We're going to start at negative 3. Slope is 2/3, so plus 2 plus 3 plus 2, that's going to go off the graph. Let's do down to left 3, like so. This inequality, I notice there's no equal to, so we're going to use a dashed line to connect these points, like so. And because we had to flip the inequality, we're now talking greater than, which means solutions are above the line. So everything up here gets shaded. Okay, next problem we have y is greater than or equal to negative 3. There's no x in this inequality, so this is just going to be a horizontal line at negative 3. And because it's equal to, we're going to use a solid line at negative 3. Now we want greater than. Greater than is going to be everything up above this line. So we can shade everything up here and try not to dip below the line. Okay, next I want to talk about systems of inequalities. You can think of this as kind of like your compound inequalities like we saw already where we did compound inequalities in one variable, and you would shade two things on your number line, right? So this is the same sort of thing, but we're going to do this on with inequalities with two variables on coordinate planes, but that's still a system. It's just simply two or more. We're going to see some with more inequalities that we consider together. And our solution to the system, it's kind of like an and statement compound inequality, right? We want to look for the intersection of the solution regions of each of the inequalities. Okay, so I've got a few problems to kind of walk us through this so you can see kind of exactly what we mean here by system and solution to these systems. Okay, the directions here are to find the solution region to the system. So we've got two inequalities. What we're going to do is we're going to graph them both on this grid. And I know the grid's kind of hard to see. I can barely see it myself, but we'll get it in the right spot. We're going to graph both of these separately, and then we're going to look at their solutions, consider it together. So I'm going to use some different colors for each of these. So this top one, I'm going to do in this kind of bright green color. So it's going to start at plus 9, and then its slope is negative 2 over 1. So down 2 over 1, we can keep doing that. And these lines are hard to see. Okay, that's enough for me. I'm going to go ahead and use my ruler to connect them. These are going to be a solid line. Solid line because there is an equal to under that inequality. And then we're going to shade everything that is less than, which is everything below. Now I'm not going to shade this too much right here because there's going to be two different shadings on this line or on this graph. And so I don't want it to get kind of too busy in here. So that's what the first one looks like. Next one I'm going to do with this orange color. That'll kind of stand out. So we're going to start at -4 right here. And we want to slope positive 1/3. So up 1 and to the right 3. Up 1 and to the right 3. I'm going to do a couple the other direction. Down 1 to the left 3. Down 1 to the left 3. Like so. We want a dashed line on this one because there is no equal to. So a nice dashed line through there. Like so. And this inequality is greater than. So greater than is above this line. So if I shade everything above this line, like so. All right, now if you look closely at this, you can see where the two shadings have overlapped. In this region right here, there is both shading from the green line and from the orange line. So I think it looks better to kind of darken that in a little bit. Got this area here below that green line, and we've got this area here above this orange line. So that's our solution region. It's going to be every point that is in this area right here is going to solve both this inequality and this inequality. All right, next problem. I'm going to go ahead and just do this all with one color marker, and I'm not going to get really crazy with the shading, and you'll see what I mean as I do this, because this is kind of more how I do it in practice. The first one, x is greater than -6. So a greater than, well, let's not worry about that, but an x equation is a vertical line. So I want a vertical line at 6, and there's no equal to, so it's going to be a dashed line right here at 6. Now greater than, this one's kind of interesting because it's x and we're greater than, but there's no above and below this line. So you have to think of this as like a number line. Greater than would shade to the right of the number line, less than would shade to the left. So I'm going to shade everything that's to the right of this line. Now, I don't want this graph to get super busy, so all I'm going to do, just to remind myself later, is I'm going to put little arrows to the right of that line, okay? And then later on I'm going to come in and fill it in when I'm all done. Next inequality, x is less than or equal to 4. So we got 4 right here. There's an equal to, so we are going to use a solid line. And less than 4 is going to be everything to the left. Okay, so right now we've got two vertical lines, and the overlap is everything shading between these two lines. If you can envision that, we want everything between here so far, nothing on the outsides. Okay, the last line is x minus 2. That's going to start at -2, and it's going to have a slope of 1/1. So just like this. And we can also come opposite direction. Okay, that's going to be a dashed line because there is no equal to on it. So about there. All right, and if we're just looking at that line only, we want greater than, which is above. So I want everything above this line. All right, so we already knew that we were confined to just between the two lines. Now we know we want between the two lines and above this line right here. So our overlapping shading of all three of these lines is going to be everything inside this area. So I show you this one kind of in contrast to the last problem where I shaded everything and then we just darkened in what was the overlap. If you prefer like this to keep your graph kind of not so busy and messy, is you can kind of indicate like I've done with these little arrows which way I'm shading, and then just shade in the solution area. Now, I haven't talked about something so far that I probably should, because this is going to come up. Now, we have said already that anything inside is a solution. right? Where all the shading has overlapped. Any point that we're going to pick inside here is a solution to this system over here. That means, that implies then that anything outside where it's not shaded is not a solution. So we got that, right? Where it's shaded, it's solution. Not shaded, it's not a solution. What about points on the line? We haven't talked about that yet. If I were to pick a point right here, is that point a solution? Or what if I pick a point over here? Is that point a solution? And the question is answered yes or no dependent on what kind of line we have. If it's a solid line is used for equals. So any point on here is equals, it's included. So this point here, yes, that point would be a solution to this system because it lives on a solid line, which is just as good as living inside here, okay? This point over here, on the other hand, lives on a dashed line. Dashed is used for not equal, okay? So any point on that dashed line is not a solution. It's definitely no. So that dashed line point is not a solution, just like everything that would be on the outside that's not in the shaded area. So that's something to keep in mind, because you might encounter some problems where you're just given a graph and then some points on the graph, and they're going to ask you, are those points solutions? So on the solid line, yes. On the dashed lines, no. Okay, this next problem I think is a fun one. We've got a system of inequalities, but we're going to pull in some stuff that we have previously done. We've got absolute value inequalities, so we need to know how to deal with that, and that's something we've talked about in a previous video. And then we're also going to find area. Okay, so I'm going to give you enough lines over here that the shading is all going to kind of shade together. It's going to make a shape. And I want you to find the area of that shape. So we're kind of pulling in some geometry stuff as well. So let's first talk about the absolute value. Okay, they're both the same in regards to less than, and so let's just pull one of them down here. Absolute value of y less than or equal to 4. So remember that a less than is like an and statement, right? And so we can rewrite this as y is less than or equal to 4 and y is greater than or equal. We flip that inequality and we make that 4 negative. So this one inequality right here is actually, because it's absolute value, it's actually implying 2, okay? And so what do those lines look like? They're both solid lines. Because they're y, they're both horizontal. So we want horizontal lines at 4 and negative 4. If I can get that right on the right spot there. And my ruler moved a little bit. That'll be okay. All right, as far as shading goes, we want everything that's less than 4, so beneath 4, and then greater than negative 4, which is above negative 4. So in essence, we want everything between these two lines, okay? Which is kind of what would happen if you think about number lines. This would have given us 2 points on a number line, and we would have shaded between the 2 points. So this makes sense. Now, let's do the same thing for the x. The only difference is this x is a vertical line. We're going to have everything less than 3 and everything greater than, we're going to flip around for the next one, negative 3. So I'm going to put my vertical lines at 3. I think that looks like 3. And negative 3. And I want everything left of 3 and right of -3. So if I'm going between each pair of lines, what I have is that shape right there. And that should be a pretty familiar shape to all of us. We all should be able to do this. That shape is a rectangle. Area of a rectangle is length times width. So across the one side here is 6 units between the two 3's, and this side between the two 4's is 8. So our area is 6 times 8, which is 48 square units. Okay, next one. Let's just get right into it. We've got an absolute value, which we now know how to deal with. We just saw that. So this is going to be two vertical lines at 5 and -5, and they're going to shade between those two lines. So let's drop those in here. Here's a vertical line at 5. Notice everything is equal to, I've already checked that over, so everything's going to be a solid line on this graph. All right, and we're going to be shading between these two lines. That's easy enough to remember, but I'll put the arrows there anyway. Next we have y is greater than or equal to -4. So -4 on the y-axis is going to put us about right here. It's a solid line. Greater than is going to be everything above. So right now we are confined to this area inside here between the two vertical lines above the horizontal line. And finally we have x plus 3 is going to start at 3 right there, and x, the slope is 1, so we're just looking 1 over 1 like so. So that's an easy enough one to plot. It's also of course a solid line, so it will look about like that. This one is less than, so we're going to shade below that line. So we want everything that was in here now below that diagonal line is going to give us a shape that looks like that. And so if you search back to your geometry course material, I think what kind of shape is that? That is a trapezoid. And how do we find the area of a trapezoid? The formula for area of a trapezoid is half times its height times the sum of its bases. Okay, so our height is the distance between the two parallel sides. So this is 10. This little piece right here is 2. And if I count this little piece, it looks like 12. So my area is going to be half times 10 times quantity 2 plus 12. So half times 10 is 5. 2 plus 12 is 14. And so my area is 5 times 14, which is 70 units squared. Okay, that concludes this video on graphing linear inequalities in two variables. If you have any comments or questions, please drop them in the section below. If you found this video helpful or you enjoyed it, please give it a thumbs up to support the channel. As always, I thank you for watching all the way to the end with me, and I'll see you in the next video.